Hello, everyone. I'm Rochak Mittal, Partner Product Manager with Microsoft. Today, I would like to talk to you about how AI is reshaping every industry. What we are seeing isn't just the next wave of technology, it's a shift in how industries will be built. AI is becoming the foundation for innovation. In fact, every organization is building with AI. Chatbots, co-pilots, custom models, teams everywhere are training them, tuning them, and putting them in front of users. And the ambition keeps climbing. And to the scale that ambition, the underlying infrastructure is more important than ever. Frontier AI solutions require high performance reliability and massive scalable compute capacity. And all of that available on demand the moment you need it. That's where Azure comes in. The same infrastructure trusted by the world's leading frontier AI labs is ready for you. So you can train, tune your models, and scale your inferencing scenarios on a foundation purpose built for AI. Let's take a look. AI workloads are redefining what the cloud must deliver. A traditional web app spreads across many small independent servers, each working on its own. An AI workload raises the bar. Thousands of powerful accelerators come together to act as one machine, moving in lockstep. To achieve the required levels of performance, an integrated approach across compute, networking, and storage is needed. Compute starts with the GPU, the engine that does the work, plus everything that turns raw GPUs into a system. How they are packaged into clusters, orchestrated, scaled, and consumed. Networking moves data between GPUs at great speed. Storage keeps every GPU operating at capacity. Every pillar must come together as one system. That's why building for AI demands system level thinking. Think of a Formula One car. The most powerful engine only wins when the fuel, the tire, the aerodynamics all are tuned to match it. Following that analogy, peak performance comes from the whole system in balance, and every scenario depends on it. Training from scratch, fine tuning on your own, and inferencing in real time. All three pillars matter. In this video, we focus on compute, the GPU itself, and the underlying system that makes it usable. Think of Azure for AI as a layer cake. At the very top, Microsoft Copilot, ISV apps, or your own agent. Below that, the AI platform, Microsoft Foundry, Azure Machine Learning, Azure OpenAI. This is where most teams build day to day. Underpinning it all is the Azure infrastructure engineered for AI, where GPU compute, RDMA networking, parallel storage, and identity are tightly integrated and are working as one. On top of advanced silicon from NVIDIA, AMD, and Microsoft Maya. If the infrastructure is fast, efficient, and resilient, every layer above inherits that performance and economics. And you stay in control across hardware, software, and the consumption model. Hardware is the raw power. Software makes it usable with the frameworks your teams already know. Consumption is how you access and pay for that AI compute capacity. Let's see how these choices come together as we double click and explore the compute component in more detail. Let's start with this compute, where choice and performance come together, and discuss the foundation building block, the node. A node isn't a single GPU, it's a collection of GPUs within a single server, interconnected via high speed fabric called NVLink, enabling them to operate as one large unified GPU. Then you take those nodes and scale them out from tens to hundreds to thousands and connect them into a single system using InfiniBand networking. NVLink inside the servers, Infinum amongst the servers. That's how a room full of servers starts behaving like a single supercomputer. And you get real choice at the silicon level. You are not locked into one GPU. There is a full range to choose from. NVIDIA's H100 and H200, the rack scale GB200, AMD's MI300X, and its huge memory, and Microsoft's own custom accelerator, Maya. Different chips and different scenarios. Pick the one that fits your model, your memory needs, and your budget, rather than adopting your workload to predetermined infrastructure constraints. Just as important, the choice in the runtime model. Some teams want full managed Kubernetes with EKS. Some just want to deploy virtual machine and run their own scripts. Other customers bring their own scheduler, Slurm, or a self-hosted Kubernetes setup they already use. Some use Azure Batch. For big offline jobs, these are open, cloud native options. The same pattern that scaled the cloud, now running AI. So whatever your team already knows runs here as is. And the system expands and contracts as needed. Spin up 1,000 GPUs for a large training runs, then scale back to just a few for a day-to-day serving, all done automatically. So you only pay for what you use, not for idle capacity. Then there's flexibility across pricing and billing models. Need guaranteed capacity for a long project? Reserve it and save. Are you deploying bursty, dev test on unpredictable workloads? Adapt, pay as you go. Have flexible, interruptible workloads. Spot capacity is far cheaper. You can match the pricing model to the workload, put it together, and the compute layer comes down to one thing: flexibility built on industrial scale performance. The fastest GPU brought together in a single system, combined with the freedom to choose the underlying chip, the tooling, and the pricing model. Now let's review the compute capabilities in the context of the first job most teams runs: inference, taking a trained model and serving it to the real users, where cost, latency, and efficiency truly matter. And this is your chosen model: an open source model or your own fine tuned LLM or a frontier model. The Azure infrastructure can serve them all. At a high level, the interaction appears straightforward. A prompt comes, the model returns an answer, but underneath, a coordinated system is constantly at work. Model is already loaded in GPU, ready the instant a request arrives, routed to a GPU that already holds it, generating the answer token by token and streaming it back to the users. And it all comes down to how fast the first word lands and how quickly the rest follows. An interesting aspect in the traffic pattern that shifts through the day, quite overnight, a rush in the morning. The system scales elastically with demand, provisioning GPUs as load increases and delocating them as it subsides, while keeping a warm pool to ensure low latency responses. Peak demand is absorbed and idle cost is minimized. The production essentials come built in. Traffic spreads across healthy GPUs. Secrets stay safely out of the code, and the endpoint is secured by default. So it's fast and production ready from day one. And ultimately, it all comes down to efficiency, matching the right GPU to the model, scaling with demand, and putting every bit of capacity to work all drive the metric that matters most for serving: more tokens per dollar per watt. And because thousands of teams run inferencing scenarios in Azure, you can rely on a proven setup. For common scenarios, there are blueprints or reference architectures outlining GPU options, how storage is arranged, how scaling is tuned. So you build on a proven foundation and customize from there. Inference is the steady, everyday scenario. Training is the most ambitious and demanding workload of all. Building a model from the ground up, Azure was the first cloud platform to deliver frontier scale training with infrastructure co engineered with OpenAI to support some of the largest models ever built. It starts with what matters most: massive compute capacity. A serious run requires thousands of state of art GPUs functioning as unified clusters, all provisioned simultaneously. And this is where Azure excels. Thousands of cutting edge GPUs tightly interconnected as a single supercomputer provisioned for a single workload. A degree of scale that's genuinely hard to match or replicate. And your model fits too. The largest model needs massive amounts of memory, so you get the choice of GPUs, high memory parts, the latest generation, matched to what you're requiring for your training. When thousands of GPUs run for weeks at a time, hardware health is essential. Azure validates nodes before the job begins, continuously monitors them during execution, and swaps in healthy capacity as needed, allowing training to resume from its last checkpoint and continue uninterrupted. Reliable compute at scale so your team can focus on the model. Across both scenarios, inferencing and training, there is a common theme. You are and you remain in control. Bring your own AI solution and let Azure handle the rest. Think of it as four control points: silicon, software, operations, and pricing. For your every workload, you tune each one of it to fit your requirements. Take inferencing. You are serving users in real time. So you reach for a GPU tuned for fast, low latency responses. Run it as fully managed endpoint on AKS and let it auto scale with traffic. Or you bring your own orchestration framework for full control over every request, and you match the pricing model to the nature of workload. Reservations for steady traffic, spot when the work is bursty and can flex. So your cost structure is aligned with demand, scaling from one user to millions. Now training, same four control points, optimized for scale. You may select the latest generation silicon and high memory options to hold the largest models and run them your way. Batch, Slum, or on your own Kubernetes, close to the bare metal. For long committed runs, you can reserve capacity and improve the economics. Conversely, for workloads that can checkpoint and resume, spot capacity brings the cost further down. The same control points apply to every scenario. You simply adjust how you use them. An inferencing endpoint and a training run sit at very different positions across these dimensions. And that's by design. Instead of reshaping your project to fit, the system adapts to fit your needs. And that's the main concept behind everything we have built. The system adapts to you. Now let's step back to where we started. AI is reshaping every industry, and AI differentiation is no longer just about the model. It's about how effectively you run the loop, grounding with data, acting through tools, learning from results, and continuously adapting. In other words, AI relies on a continuous system loop, and the infrastructure that runs that loop efficiently is where differentiation can happen. That's the core idea behind Azure. The hard part is handled. Thousands of the most advanced GPUs unified into a single supercomputer and kept fast, continuously supplied, and resilient. So you can build with AI without having to become a supercomputer company. And it's all in your own terms, your chips, your frameworks, your way of working, managed for you or for your own control. Serve a model to millions or train the next one from scratch. Either way, the system shapes itself around your requirements. So here is what I would like you to remember. The model is yours to build. The infrastructure is ours to run. The world's leading AI labs already rely on Azure, and the same foundation is ready for what you build next.